In this video, I'm going to show you how to find the intersection between L equals 3 secant of theta plus 7 cosecant of theta and L equals 15. So as you can see from the calculator, you don't have the button for secant theta or cosecant, but we know that secant of theta is 1 over cosine theta and cosecant theta is 1 over sine theta. So I'm going to use that information. Also, in the calculator, it's true we don't have theta, but if you want to graph, for example, sine of theta, if you want to see the graph, if you press y equals and you put sine of x, the calculator already knows that this is going to be your angle, and when you graph it, you get the graph for sine. So even if you don't put theta specifically, x will do. But just make sure that when you do your mode is written in radian, it's selected, not in degree. So now let's go back to our problem. I'm going to go to y equals, and I'm going to clear this out, and I want to write 3 secant theta. So I'm going to put parentheses, 3 divided by cosine theta, but I'm going to put x because I don't have theta, and I'm going to close all the parentheses. This is exactly the same thing as 3 secant theta plus 7, parentheses, 7 divided by, and it was times cosecant theta, so I'm going to put divided by sine theta, but I don't have theta, so I put x and close both parentheses. So if I press graph, I'm going to get the graph of that function that I wanted. Now, maybe my window is too crowded here. If you read the problem carefully, theta is between 0 and pi over 2. So I'm going to restrict this by going window, and I'm going to put x between 0 and pi over 2, second power, because this is pi, and divide by 2. So see how my graph looks like now. So it looks something like this. It took some time to upload. I'm going to adjust also the y because I don't need it to go to from negative 170. So I'm going to put from negative 10. You adjust the window based on the values that you have in the problem. And let's say it goes to up to 20. So this is my new graph. But I also want to find the intersection between this line L and L being 15 or 14, or it depends on the problem. As you can see, I changed the numbers a little bit so that you can practice with your own problem. And if I press graph, I notice that these two L's are intersecting at 2 points, 1 point here and 1 point here. So how do I find the intersection? Go second trace, and I want the intersection. It makes sense, right? 5. I'm going to press 5. And now, first curve is this one. Yes, I press enter. Second curve is this one. It just actually moved to the next line. I see how it's blinking. Enter. And then I press enter again, and it gives me the point of intersection between those two. So you go second trace, and then you press enter 3 times. And then, so the intersection between those two, the x point is 0.68. They were asking for 2 decimals. So that x stood for theta in our problem. We just because the calculator is using x as the variable, we use that. Now again, I want to find this point. So I go second trace, and again 5. But again, my point is all the way here. So I'm going to move a little bit closer to the point that I want with this red arrow, and I press enter. So is your first curve the one that we have here? Yes. So I'm getting closer to the point. Then I press enter again and enter again, and as you can see now it's blinking the intersection between here. So the other point is 1.15. So your answers that you're going to put in MyLab Math are 0.68 and 1.15. I hope this helps.